Hi everyone, welcome back to this series on measurement. This is video number 9, the surface area of pyramids. I should warn you that this is probably the most difficult content in this topic. I'll try to break it down for you as best as I can with 2 examples. So we'll start with an easier example, one where I've told you that the slant heights are known. So what are the slant heights? Think of these as the heights of the triangles if you were to walk up each surface. So they're not vertical heights, they are slanting heights, slanted in the same direction as the face of the triangle in the pyramid. Okay? So we need to go back to our previous strategy for finding the surface area of a prism. If there is no simple formula available, what we will need to do is break up the shape into different faces. So here there are 5 faces. First of all, there is a rectangle at the bottom with dimensions 12 meters by 16 meters. And then there are 2 triangles. One has base 12, height 12.81. The other one has base 16 and height 11.66. And we want to count each triangle twice. Since this is a rectangle, the sides on the left and the right are going to be the same, and the sides on the front and the back are going to be the same as well, although this is difficult to draw in 2 dimensions. Okay, so the total surface area in this instance is going to be the area of the rectangle at the bottom, which is 12 times 16, plus the area of the first triangle, half times 12 times 12.81. And then I'm going to double it because I'm counting this front triangle twice. And then I'm going to add the area of the second triangle, which is half times 16 times 11.66. And then I double it because I'm also counting the left and the right triangle twice. Okay. You might be wondering why I gave such specific numbers with 2 decimal places here. Normally I don't do that. And the reason is I can't just pick any numbers for this. In order for this to work as a pyramid, with all the triangles meeting at one point, the numbers have to be consistent. So if I fix the vertical height from the apex to the middle of the base, then I'm limited in what numbers I can choose here. So anyway, that's why we get these specific numbers, and now it's a simple matter of doing the calculation. So we can actually simplify this because the 2.5 will cancel each time. So I'm just left with this calculation. And at this point, I will need to use a calculator. Okay, so the number isn't as important as the process that we went through to do this calculation. All we did was we added the areas of each individual face together and then got the total, which in this case was 532.28 square meters. So hopefully this wasn't too bad. And the reason why this example was sort of easy was because I gave you these slant heights on the pyramids. If I didn't give you those, then this would be much harder to do. So the next example, we'll do this without the slant heights and we'll have to work them out. Okay, so here is another rectangular pyramid. And we have to assume in this question that the top of the pyramid is vertically above the center of the base. This isn't stated explicitly in the textbook, but you've got to make this assumption, otherwise it's not exactly clear how you would go about doing the questions. So what I'm going to do is I'm going to draw the slant heights in again, in purple, and I'm going to call this slant height X, and I'm going to call this slant height Y. The reason why I have to use two different slant heights is because this is a rectangle, 20 by 12 on the bottom. So I'm expecting that the slant heights will be different depending on the direction that I'm going up the pyramid. And now we need to think in 3 dimensions. So let's start by considering slant height X. The height of this pyramid is 8. Slant height is X. How far is it to go halfway along the side length of 12 meters? And the reason why it's halfway is because the top of the pyramid is meeting, well, I should say the top of the pyramid is vertically above halfway along the base. So this side length here is going to be 6 meters. Okay. Similarly, if I think of the other slant height Y, the height of the pyramid is still 8, but this time I'm going halfway along the side length, which is 20 meters. Half of 20 is 10. So now I've got a situation where I need to use Pythagoras' theorem to solve for X and Y. So let's go ahead and do that. I'll just do this in full. So the square root of 100 gives us 10. This should be familiar to you. If you've done Pythagoras, you know that 3, 4, 5 is a right angled triangle. And if I double 3, 4, 5, I get 6, 8, 10. Now for the second triangle, we're not going to get a nice straightforward value. Here we'll have to use the square root function on our calculator to get a decimal. Okay, so y is root 164. Go to our calculator, and we get 12.81. I'll just round that to 2 decimal places. Actually, we can just keep the exact value. And we can actually simplify this to 2 root 41. Don't worry if you don't know how to do that, you can just use root 164, you'll get the same answer at the end. Okay. Why did I want the slant height? Well, the total surface area is equal to the area of the rectangular base plus 2 times the area of the triangle with slant height X plus 2 times the area of the triangle with slant height Y. You don't have to write this line, but I'm just sort of showing you what I'm thinking here. Right, so the rectangle has area 20 times 12. The triangle with X has area half times 20 times 10, because we found the slant height was 10. And then I want to double it because I'm counting that triangle twice for the front and back. Then I want to add the area of the triangle with slant height y. This is 12 times 2 root 41. And I want to double this as well because I'm counting the left and right triangle twice. The 2's and the halves cancel. So this leaves me with 20 times 12 plus 20 times 10 plus 12 times 2 root 41. So that gives me 240 plus 200 plus 24 root 41. I'll just create a little bit more space here. There we go. So this leaves me with 440 plus 24 root 41. And at this stage, I can now simplify this and get a decimal answer with my calculator. So here I get 593.67. And again, the number isn't as important as the process that we went through. So really, this step demonstrates your understanding. You're finding the area of a rectangle, the triangle with slant height x, and the triangle with slant height y. When you do the textbook work, you will also deal with triangular pyramids. And in general, the strategy is the same. If you need an unknown slant height, or you need something that's not given to you, it's likely that you will need to use Pythagoras' theorem. I've certainly noticed that this was a much more difficult video. The next few will be much easier. Thank you, and see you in the next one on volume.